Tell me about a type 1 error.
A type 1 error is that in a hypothesis testing, we get a true null hypothesis.
Okay, so calling it a type 1 error is pretty imaginative, huh? There's a lot of creative thought to call the two errors that you can make, type 1 and type 2. But in any case, a type 1 error is rejecting a true null. Tell me about the other kind of error that one could make in hypothesis testing.
Type 2, accepting false.
Okay, so accepting a false null would be the other kind of mistake that one could make.
Wouldn't it be better to say failing to reject a false null?
Well, yeah, but the common way to state it is accepting a false null, even though I agree with you. Which is the more egregious error, type 1 or type 2?
Yeah, it depends on the situation. For example, legally, you said the big thing in this domain would be that the more trying to get to the end, and so that would be that we accepting a false null.
In light of all the things that we said the first couple of nights of class and all that business I had to go through with the wine and the crime and what was the other day? Wine and crime?
Temperature.
Temperature and economic activity. Do you think that the more egregious one is accepting a false null? Or rejecting a true null?
Like I said, it depends on how you're really looking. Off the bat, you can't say,
Which probability, we make a type 1 or a type 2 error with some probability, right?
Yeah.
Which one of those do we ordinarily pick? The probability of a type 1 error or the probability of a type 2 error? And we always pick the probability of a type 1 error, and what numbers do you usually pick? Yeah, 5%, 1%, 10%. We don't really give it very much thought. We just say, this test statistic is significantly different from 0 at the 5% level in a two-tailed test. And without giving much thought to why we pick 5%, or 10%, or 1% for that matter, right? So why don't we think about it more? And should we? And why should we? So Tim says, now he's revised his thinking a little bit. He thinks maybe the type 1 error is more serious because we always choose a very low probability for making that mistake. Is the probability of making a type 1 error at all determinative of making a type 2 error?
Yes.
And in what way is it determinative? How are they connected to one another? No, I don't think so. So Jose says that he's right in that the probability of a type 1 error is determinative of the probability of a type 2 error, but he's not right when he says that the two have to sum to 1.
the smaller that we make the probability of type 1 error, the larger the probability of type 2 error becomes.
Why did you decide that? Or how did you decide that?
Because we're honing in on just type 1 error. We're looking at refining our type 1 error. Trying to make it easier for us to not make a type 1 error, and with that we're kind of neglecting the type 2 error.
Yeah, that's the sense in which I think Jose told us that picking alpha was determinative of what the probability of a type 2 error was going to be, but I'm still trying to develop this idea a little bit more. Why don't they add to 1?
Well, they're just mutually exclusive. See, what happens is...
That's okay. Two faces of a coin are mutually exclusive too, and the probability of the head and the probability of the tail add to 1.
Type 1 error is related to power. See,
I'll buy that. Go ahead.
the power is the power to detect a type 2 error. If there was one there, so...
Oh, you're so close.
I know I'm close.
What's the power of a test?
The power of a test is, if there is a difference, it's the power. That
It's your ability.
Your ability to tell you if there actually is a difference, in this analysis.
Okay, so the power of a test is the extent to which the test allows you to distinguish between what's true and what you believe to be true. Okay? So that's the power of the test. So what's that got to do with the probabilities of...
Well, I'd like to finish it up.
Okay, go ahead.
The type 1, that's your alphabet, like your kernel power like that. So what happens is, like, the thing that sums to 1 is the probability of both your type 2 error plus plus the chance.
If you don't reject a true null,
It's either
then you must have
inconclusive.
not rejected it.
Yeah, which is a combination of inconclusive plus the true rejection. You know, I mean, the true acceptance or the inconclusive.
What adds to 1 is the probability of rejecting a true null and the probability of not rejecting a true null. That has to add to 1.
Yeah.
But that's different from a type 2 error, which is the probability of accepting a false number.
Yeah.
There's a little example in the lecture notes that are online where, and this is where it becomes most apparent when we're talking about, I don't recall the specific example, but the mean is, the null hypothesis is that the mean is equal to some particular number against the alternate hypothesis that the mean is equal to some other number. If we put on the horizontal axis all the things that could be true, that's the truth, and we put mu0 in there, then we measure on the vertical axis the probability of rejecting the null, right? And we get to pick the probability of rejecting a true null. Suppose we would hope that by our statistical testing method, that if the truth is different from our null hypothesis, that we can distinguish between them. And if the truth is a lot different from what we believe to be the truth, the probability of rejecting our null should be quite high. As a matter of distribution theory, if there's hardly any difference at all between our null and the truth, the probability of rejecting the null is going to be quite small. Because it's very hard for us to tell the difference between the null, which might be 1, and the truth, which is 1.1. On the other hand, if the truth was 10, we would hope that we had a statistical technique that would allow us to tell the difference. So we hope that the probability of rejecting the null rises as the truth gets further away from the null in either direction. And that's known as the power curve. So we get to pick alpha, the probability of rejecting a true null, and the power curve tells us the probability of rejecting the null, even when it's false. Is there only one probability of a type 2 error? Oh, and this, by the way, this picture, by the way, is for a two-tailed test. The spot in the notes where the picture that goes with this one that I produced was to put the distribution of the sample mean centered on the null hypothesis. And we have a technique whereby we reject 5% of the time, 2.5% in each tail, say. Suppose, however, that this is the alternate down here, and here is the truth. Suppose that the alternate hypothesis is true. When the alternate hypothesis is true, the probability of rejecting the false null is the area in the two shaded tails. In the right panel that I drew, we don't know. We don't have a specific alternate. So we're considering them all. So here, where either the null is true or the alternate is true, my power curve consists of only 2 points. But I'm considering an alternate.